All right, so the next part of the first section of the unit is dealing with Euler's method. So Euler's method is used to approximate values of a function when all we have is the differential and we cannot solve it. So we can take x values and find out what the y value output for the original function would be without actually knowing the original function. So it's not perfect, but we can get close enough depending on a couple things, and we'll talk about that here in a little bit. So the first problem that we're going to have is the differential x plus y. So let's go ahead and take a look here. So if you're given a differential, you have to know a starting point in order to do any Euler's problem or any approximation. You have to have that. The other thing that you are usually just told what it is, or you have to figure it out, is the change in x. So we're moving our x value up by 0.1 in this case. Sometimes they tell you where you're starting and where you need to get to, and they tell you how many equal steps you need to do. And you just divide the difference by however many steps you have to find that jump. But we need 4 things in order to do these problems. So we need an x and a y, which we have. We're starting with an x and a y. We need to be able to calculate slope, which we should be able to do with our given differential. And then we need to find out what the change in y is. So all we have to do there is multiply our slope that we found by our change in x, and that should give us the change in y. So let's go ahead and try one of these, and then we'll run through another one. So we start with our 0, 1, so our starting x and y. We're able to plug these into our differential. So 0 plus 1, that would just be a slope of 1. And now we're going to multiply our slope by our change in x. So our change in x is 0.1 times 1, which is 0.1. And then the next thing that we do is we take our x and we change to whatever our change is. So 0 plus 0.1 gets us to 0.1. Our goal is to end up at x equals 0.3. So we'll get there in a couple steps. So 0.1, we need to find the y, so we use the change in y to find that value. So 1 plus 0.1 is 1.1. And then we can go ahead and calculate slope for this point. So we add the 2 together, and we end up with 1.2. Multiply by the change in x, so we get 0.12. We just continue on in this fashion. So add 0.1, so we're at 0.2, and then we add our change in y, so we end up with 1.22. Add them together, so we end up with 1.42 for our slope, and then multiply that by 0.1, so 0.142. And we continue on. So 0.2 plus 0.1 is 0.3. So we're at our target. So that's our target x. We need to find the y. So whatever we get here is our answer. So we're adding on this change in y to our previous y. So we end up with 1.362. So this right here is our approximation at x is 0.3. That's all we got to do. So let's go through one more here. So we have a differential, negative x over 2y. We have a starting value, or starting point, coordinate, 1, 3. Our change in x is set to 0.5. And we need to find y when x is 3. So we're starting off with a 1 and a 3 for our x and y. Our slope we're going to find by plugging into the differential. So we get negative 1 over 6, which is 0.167, I believe. So negative 0.167. That's our slope. So change in y, we're going to calculate by multiplying our slope by 0.5, and we end up with a negative 0.083. So remember, we're adding our change in x to x, so we go to 1.5. And we can lay this out. Some people prefer to do this, so we go 1, 1.5, 2.5 to 3, just so we know how many jumps we got to make. So a couple more calculations here. So go ahead and add on the change in y. So we get add on our to our 3. So we have negative slope, so we're going down 2.917. And we can keep rolling through this and plug in our values. So we get negative 1.5 divided by 2 times our previous answer, and we get a slope of negative 0.257. Multiply that by 1/2, or 0.5. We get negative 0.129. We keep going. So we're adding this on over here to this value. So we get 2.788. And keep going. So eventually, what we're going to get is an answer down here when x is 3. So you can keep rolling through this process. I'm not going to take up your time just calculating these. I think you got the process by now. If not, let me know and we can talk. But just go ahead and ask questions, and hopefully it goes well. So have a good day.